Good day everyone, we're going to present our topic which is linear programming application. We'll see how this powerful quantitative analysis tool is used in real-world business scenarios, specifically in marketing and advertising. So next is ang first outline of this topic which is marketing applications. So linear programming or LP is a versatile mathematical technique and it's been a significant aid in the advertising field for selecting an effective media mix. Essentially, ang linear programming helps decision makers allocate a limited budget across different advertising options. So, media selection LP problems can typically be approached from two perspectives. First is maximize audience exposure. Then money is given a fixed budget and constraints. How do we reach the largest possible audience? Then ang pangduha is minimize advertising costs. Then given a required minimum audience reach, how do we spend the least amount of money? The next is maling example sa marketing application. So let's introduce our clients which is the Win Big Gambling Club. So nay budget nga $8,000. So kaning Win Big Gambling Club is they promote gambling junkets to the Bahamas and are looking to optimize their advertising campaign. So na sila key parameters o constraints. Constraints means is kanang limitation for their weekly advertising effort. First is they have an $8,000 per week budget to spend on advertising. Then their main goal is to reach the largest possible high potential audience. Then last is they have some media constraints, which is they must place at least 5 radio spots per week and they can spend no more than $1,800 on radio advertising each week. So next is ang advertising option. Data table ni siya, which is nakabutang is medium, then audience, reach per ad, then cost per ad, then maximum ads per week. Then first is TV spot for 1 minute is reaches 5,000 people at a cost of $800 with a maximum of 12 spot per week available. Then sa pangduha is daily newspaper full page ad reaches 8,500 people at a cost of $925 with a maximum of 5 ads per week. Then next is ang radio spot for 30 seconds prime time reaches 2,400 people at a cost of $290 with a maximum of 25 spots per week ni siya. Then radio spot for 1 minute afternoon lang is reaches 2,800 people at a cost of $380 with a maximum of 20 spot. So there is manotice na to ang huge difference in reach and cost. This is precisely why we need linear programming or LP to find optimal balance. Then next is problem formulation. So diri is na gamit of variables such as x1 represents the number of 1 minute TV spot taken each week. Then x2 is equals to number of daily newspaper ads taken each week. Then x sub 3 number of 30-second primetime radio spot taken each week. Then x sub 4 is equal to the number of 1 minute afternoon radio spot taken each week. So ang objective no is makuha ang maximize audience coverage. Then ang formula para makuha ang maximum audience coverage is 5,000 times x sub 1 plus 8,500 x sub 2 plus 2,400 x sub 3 plus 2,800 x sub 4. So subject to x1 is less than or equal to 12, mo ni siya ang max TV spots per week. Then ang x sub 2 is less than or equal to 5, which is maning max newspaper ads per week. Then x sub 3 is less than or equal to 25, then max 30-second radio spots per week ni siya. Then x sub 4 is less than or equal to 20 morning max 1 minute radio spots per week. Then 800 times x sub 1 plus 925 x sub 2 plus 290 x sub 3 plus 380 x sub 4 is less than or equal to $8,000 morning weekly advertising budget nila. Itong kagainan na nakabutang sa description. Then next is x sub 3 plus x sub 4 is greater than or equal to 5. Pasabot man yung minimum radio spot na contracted. Then 290 times x sub 3 plus 380 times x sub 4 is less than or equal to $1,800 or ang max dollars na na-spend on radio. So, x sub 1, x sub 2, x sub 3, x sub 4 is greater than or equal to 0. So, next is ang solution in Excel 2013, ang solver na setup. So, we use a tool like the Excel solver which employs the simplex LP method to find the optimal values for our decision variables. So, ang key solvers is mag-input siya og set objective, the cell containing our total audience coverage formula to be maximized. Then, by changing cells, the cells corresponding to x sub 1, x sub 2, x sub 3, ug x sub 4. Subject to the constraints, all the constraints we just discussed are entered into the solver dialog. So the key to the audience calculation is the sum product formula which multiplies the number of ads x sub I by the respective audience reach and sums the results. Then as a result, running the model provides the optimal solution. The number of spots we should purchase each week are x sub 1 is equals to 1.97 which is ang TV spots. Then x sub 2 is equals to 5 which is newspaper ads. Then x sub 3 is equals to 6.2 which is 30-second radio spots. Then x sub 4 is equals to 0 which is ang 1 minute radio spot. Pero sa TV spots or sa radio spot is dili ba yung mga buy or mga palit o 1.97 or 6.2 na radio spots. So sa practical media buying scenario, this would typically need to be whole numbers. So i-round off siya to the nearest, which is ang TV spot is mahimo siyang 2, then ang radio spot is 6. The next is continuation siya sa solution in Excel 2013 for the Excel output. So this slide shows the Excel solver output, the solution row which represents x sub 1 through x sub 4 is what we just discussed. If we use the fractional optimal solution, kung value kagain is katong para makuha ang maximized audience, itong formula na x sub 1 times itong given na audience reach is come up siya, total audience ma-reach is 67,240.3017 people. So, i-review, the maximum TV spot is 12 and 1 minute radio spots 20 are not binding, meaning we didn't use all of them. The next is the maximum newspaper ads, 5 is binding, meaning we use the limit. Then the total budget $8,000 is binding, meaning we spent the entire amount. Then both radio constraints and minimum spots greater than or equal to 5 and max dollar na less than or equal to $1,800 are also binding. So the best way to the Win Big Gambling Club is to maximize its reach is focused heavily on the daily newspaper ads and a mix of TV and the cheaper 30-second radio spot, while completely ignoring the more expensive 1 minute radio spots. Then, the Win Big Gambling Club case demonstrates how linear programming is an essential tool for managers to make constrained resource allocation decisions by balancing cost, reach, and various restrictions. So LP or linear programming delivers the mathematically optimal path to achieving a marketing objective. So next is manufacturing application. Production mix LP can be used to plan optimal mix of products to manufacture. Company must meet a myriad of constraints. First is financial concerns, sales demands, material contracts, union labor demands. So primary goal is to generate the largest profit possible. So next is Fifth Avenue Industries, maximizing profit through optimal production. So we've all heard saying time is money, but in manufacturing the real phrase is the right mix is profit. So Fifth Avenue Industries produces 4 varieties of ties, from expensive all silk to various blends. Our goal is clear, maximize monthly profit. So I will introduce the decision variables. To achieve this, we need to determine the optimal number of each tie to produce. We define our decision variable as x sub 1 all silk ties, x sub 2 all polyester ties, then x sub 3 is polycotton blend 1 ties, then x sub 4 is silk cotton blend 2 ties. So the next 2 slides is the data of the Fifth Avenue. So our main objective is to maximize profit. The profit contribution for each type variety is calculated by taking the selling price and subtracting the material cost. This gives us the following objective function. First is the constraints, or what limit us to find the optimal production mix. We must operate within a series of constraints. These constraints fall into 2 main categories: material availability and contractual demand. So showing the result, the optimal solution recommends the following production quantities per month. So through sa Excel na solver is morning result. All silk is 5,112 ties, all polyester 14,000 ties, polycotton blends 16,000 ties, then silk cotton blend 2 is 8,500 ties. So ang final profit is by adhering to this mix, Fifth Avenue Industries can achieve the maximum possible profit of $412,028.88 per month. So there is ang LP or linear programming model effectively balance material scarcity with contractual requirements and sales potential, ensuring the maximized profit efficiently.
Financial applications. So here you can do apply in the case of financial applications portfolio selection if you want to maximize your profit. So here's an example of a company that want to invest many things: trade, credit, bonds, gold stock, and loans. So there they have interest and also a maximum investment they can. Okay, so they have a total of this much to invest, and what is important in them is, of course, to return a huge amount of money. To return the investment must be high, or the return of investment must be high. Then they have decided to at least 55% should be in gold stocks, and constructions, lands, and strictly no less than 15% be credited, or credit rather. So here we have given the International City Trust variables. X1 equals dollars investment in a trade credit, X2 is the dollars investment in the corporate bonds, X3 is the dollars invested rather in gold stocks, then X4 is dollars invested in construction loans. And now we can make up. So here a summation of maximize dollars of interest earned is 0.07 x1 plus 0.11 x2 plus 0.19 x3 plus 0.15 x4. So here pinlog in lang natin yung given conditions sa problem. Sabi ko kanina, they have a condition of submission. Then the total 5 million here is the maximum they can spend. And again, we can also use some tools to calculate the answer for that. Also, we have IDA, the ingredient blending application. For example, this is a very common or a popular LP problem. It's also called feed mix problem. Like for example, for a patient, they wanna give the items or some items rather. They will say that these are the nutrients and these are the requirement for the patient. And also to reach this, they have some items here, the A, B, and C. So what is the cost of them, or and how much protein they have, and also this for nutrients. So okay, the values are given. So again, we have the some condition. Then if we want to minimize the cost, so the costs are given there. So ang kailangan lang natin ay i-plug in natin yung given condition and given value sa problem. So take note that make sure there is no non-negativity, and of course again you can solve the problem using other tools and get some answers. Is the other LP applications. So here you can apply LP also in the revenue management, where you can apply to how many seats is available for each type. You can apply hotel industry. Then you can also apply the data envelopment analysis, or the to measure efficiency of similar operating units. Then you can see, like for example, if I have a company which is working, whether I'm meeting all the objective or not. Then and we want to optimize objective is to minimize the resources required to generate the required output, and also identify the areas we want to improve or make some improvements for it. We have a transportation, transshipment, and assignment problems. So it is so very widely used in business, and its special purpose is the algorithms have been developed, and also it allow more rapid solution for of these types of problems. So it could be it also could be solved by the other tools like Excel, and this topic also is would be presented by the other reporters. So that would be all for our reportings. Thank you very much.